Okay, so now I want to talk about some puzzles related to an area of maths which I think is simply fascinating. It's all about prime numbers. So if you don't know what prime numbers are, then I feel honoured to explain it to you because I think they're some of the most fascinating things in the universe. Right, so what's the best way to explain it? Physical objects, like this blanket, say, they're made out of chemicals. So chemists would say that the fundamental building blocks of a blanket would be various different kinds of chemicals, carbon, hydrogen, whatever. So chemical elements are the fundamental building blocks of physical substances, and prime numbers are the fundamental building blocks of numbers. So every whole number, every integer, we call whole numbers integers, every integer can be broken down into prime numbers in a unique way. And so, in some sense, every number is kind of made out of prime numbers. And some mathematicians think that everything in the universe is made out of numbers. So if everything's made out of numbers, in some abstract sense, and every number is made out of prime numbers, then prime numbers should be pretty important. And you would have thought that since maths is all about regularity, and prime numbers are one of the simplest things in maths, that they should be quite regular. But they ain't. They ain't regular at all. They are immensely complicated things. And in some sense, some mathematicians believe that there's some kind of randomness there, even though they have no sort of way of explaining where it comes from. It's very, very interesting. So in order to tell you what a prime number is, all I have to do is explain to you what a factor of a number is. So a factor of a number is just something which divides by it. So, for example, 12 equals 3 times 4. So 4 is a factor of 12. Okay? So some numbers have lots and lots of factors. Like 12 has quite a lot of factors, okay? Let's write them down. So 12 equals 1 times 12. It's also equal to 2 times 6. And it's also equal to 3 times 4. Okay? So you can see that we can factorize 12, we can break it down in lots of different ways. And you can think of it geometrically if you like as well. For example, if you draw a sort of rectangle, 3 dots across and 4 dots up, then in total you'll have 12 dots. So you can think of all of this stuff geometrically. But anyway, the number 12 is not a prime number because it has factors which are greater than 1 and less than 12. Like, we can write it like this, 2 times 6. So 13, on the other hand, is a prime number because the only way we can factorize 13 is to write 13 equals 1 times 13. We can't write that 13 equals 2 times an integer or 3 times an integer or 4 times an integer, etc. The only factors of 13 are 13 in itself. So now we have our definition of a prime number. So we'll say that a number is prime when the only factors it has are 1 and itself. Okay? So you'll see that prime numbers are really special because, as I said before, all numbers can be broken down into prime numbers. Let me show you how to do that. Let's say we start with 24. That's got a lot of factors, it's 24. So let's start breaking it down. Well, we can split it up like this. 24 equals 2 times 12. What are the factors of 2? Only 1 and 2. So 2 is prime. Okay? We'll put a circle around it. What about 12? Well, 12 can be split again. It's 2 times 6. Again, 2 is prime. And we can split 6 into 2 times 3. Whoops. And 2 and 3 are both prime. So what we've done now is we've broken down 24 into prime numbers. So you can write it, if you like this. You can say 24 equals 2 times 2 times 2 times 3. And so we've broken down 24 into prime numbers. And you can do that of any number at all. So every number has a special way of being broken down into primes. And that basically means that all numbers are made out of primes. So then the question burns, what are the prime numbers? What is the sequence of prime numbers? I mean, you know, people talk a lot about sequences in maths, like the square numbers. Okay, they go 4 and then 9 and 16 and so on and so forth, and it's pretty easy to comprehend the sequence of square numbers. But the sequence of prime numbers, it's a lot more interesting. So my first problem for you, better start with something simple. Let's see if you can find out the first prime number which is larger than 80. Okay, so some tips for you is if you just look at the numbers and then think about what numbers divide into them and see if you can find the first prime number larger than 80. Okay, so if you can do that okay, then my second problem for you, it's a bit more challenging, is to see if you can find the first prime number which is bigger than 320. See if you can do that. Now, if you want to really challenge yourself, and you haven't seen this before, then this is a real challenge for you. Are there a finite number of prime numbers? Do the prime numbers stop, or do they go on forever? Can you always find larger and larger prime numbers? So if you can answer that question and sort of prove it or come up with a convincing argument, that would be exceptionally good. I mean, there's a really famous argument about this, but you know, if you find your own, then hats off to you. Okay, then. So what about open problems about prime numbers? Well, there are just so many. Basically, the big open problem is, what are the prime numbers? Nobody knows the sequence. There are formulas which will give you the nth prime number, but those formulas are impossible to use, basically. It's like there's a formula, but if you're actually going to use it to compute something, it'll take, to find the 1000th prime number using this formula, it'll take forever. So no one knows a kind of easy way to find out what the prime numbers are, and no one knows really if there's a pattern. And the general consensus at the moment is that there is no pattern, not really. But let's see if I can give you a concrete problem about prime numbers. So there are such things as twin primes. These are primes which vary by 2. So an example of some twin primes would be 3 and 5. Okay? These are twin primes because they're both primes and the difference between them is 2. Now, here's an open problem for you. Are there an infinite number of twin primes? In other words, can you always find larger and larger pairs of twin primes? Or is there like a certain level, like after 1 billion there are no more twin primes, or something like that? Which is the case? Is there an infinite number of them? Or do you run out of twin primes at some point? This is an open problem. No one has any idea. So, I mean, if you could solve one of these things, you would instantly get like whatever kind of maths job you want, and you'd be really famous. So, it might be worth trying.